So you have to ask a question like, what is mathematics if you're doing metamathematics, but you don't have to answer it, at least not right away. But one of the things we're seeing, and one of the things we saw with Kurt Gödel, was that there are tensions holding anything together, and one of the tensions in mathematics is the tension between aesthetics on the one hand and rigor on the other. Elegance being one of the core words of mathematics. It's impossible to have something which is beautiful and elegant which does not have any rigor at all. That's a contradiction. But total rigor is dead, and that was never the intention of mathematics. So metamathematics makes me just tired just saying it, let alone hearing it. Fortunately, we have an older and better term for it, which is Hermetics. Okay, so we're going to get weird for just a second. So if you have mathematics, science, and language, then of course at the intersection you have Hermetics. Also you have Hermetics. I think this makes sense to all of us, right?
Yeah.
Okay. So as within, so without. So sooner or later this stuff has to get important, I figure, which is where computers and the future of the internet comes into play. So what do we do with these devices that we have? Do we do math with them? Absolutely not. I mean, I happen to. I'm this bizarre exception to the rule, and they have to pay me. I don't normally do math like for fun. But we must use mathematics to use them. This is non-optional, because that is what they're composed of. Now, progress in mathematics has become higher and higher caliber of brain and deeper into an impenetrable place where the insights gained are very difficult to return and use, which was also not the intention. And to me what this indicates is that there are problems with the symbols and the abstractions being used at the bottom level. So much of what I focus on has been an attempt to address that. So when we were talking about these the dimensions earlier, many of you know my fawn project, so it may interest you to know that in mapping out those dimensions we have 0, 1, 2, 3, 4, 6, 8, and that's what I get for doing this in extempore, because I got two of them backwards. But so rather than plus and minus, so we can keep everything straight, it turns out that something that I came up with as a pet writing project many years ago maps exactly to these dimensions quite easily. So we've got an up and a down, the up-down rotation. First extension, this is the what we'd call the y-axis, and then the rotations around the y-axis, and the z-axis, and the rotations around the z-axis. That also leaves us with a couple of symbols for reflection, which is kind of nice. And then there are 4 symbols left that are actually, those 4 are selected from the 16, and they're a compound and they relate to scale. Scale being an important thing. So we talk about these dimensions. It turns out that 3 of them are space-like and 3 of them are time-like, which is kind of cool. You know, we have translation in these 3 dimensions, which creates an orientation of space, and then there's the rotation around each of them, each of which is periodic, each of which is independent. And periodicity is one of the qualities that we associate with time, but time is a conflated concept, because we have some pseudo-dimensions that we also deal with, we might call them qualities, that present dimensional characteristics but are not actually dimensional, one of which is scale. Scale is a very important example of this. We see recurring patterns throughout scale, but scale has a ladder-like quality. There's an outer scale and an inner scale. And that's not truly dimensional. These rotations, these translations, they are absolute. They apply, as far as we can tell, without exception.
Only those 6, only the 3 rotations and the 3 extensions.
Well, yes, and so this is, and I just wrote this down this morning, but these are the way that I'm going to do these axioms. So we got axiom 0 is the point, axiom 1 first extension, axiom 2 first rotation, axiom 3 is the 2 recursions that are possible, so the extensions and rotations. 4 is the equivalence of all extension rotation pairs.
Okay.
So you can pick them in whatever order you choose. You will always end up with the same number, but your orientation will just be your orientation, because you get these things, you're a blob floating in space, no orientation.
Yes.
You grow out an extension, you now have an axis,
Yes.
which you are allowed to spin around
Yes.
because you have one. Simple properties of nature being what they are.
Yes.
So on for the others, and then you're done, because there are no more ways to extend or spin. The 5th is the metacircularity of space-time. Yeah, And that is the conclusion, that because we reach a point where we can no longer extend and rotate, we therefore must be on a larger circle that we can either extend or rotate on, also known as the space-time manifold. So another dimension-like quality that we run into is...
Is that like a ring pass knot?
Pardon?
Is that like a ring pass knot in the follow?
Like the remnant of bonds.
Part 2.
Part 2, I think.
Part 2. Okay, so this is important stuff, okay? Because every single one of us, including me most of the time, is convinced that we live in a 3-dimensional reality with this time-like dimension. Whereas we live in a 6-dimensional reality with at least 2 dimension-like properties. 3 of those dimensions and 1 dimension-like property we totally conflate into a time thing. And then there's scale, which is a way that we deal with the extension rotation stuff. Mostly just the extension. We're a lot better with the odds than the evens in this. I did want to get into some of the implications here for special relativity, but I just don't think I can hack it right now, and I don't want it to come out like a mess. But if you think about what's being said here, so when you have the Lorentz transformation, things are moving faster, and they get smaller from some other perspective. Also, there's a time thing that's happening, which is spin, fundamentally. That what you will see is you'll see more spins as something is moving, which is what creates the difference in time perspective. And all I want to say right now is that I'm pretty sure that somewhere in there is actually room for a concept of simultaneity, which is controversial. So what's the next one? Something else we get backwards routinely being in the gravity well is the idea that 1s are up and 0s are down. I kind of get it. It makes a certain amount of sense. All of the light comes from outside onto the planet, and if you go into caves, it's dark. But Lisa looks puzzled. She's been off that page for a very long time. But keep in mind. Okay. But we're gonna do this. So zero's orbit or ground state. The reason this is interesting is where do you keep your low significance when we get to the computers, which we're going to do relatively soon. So 1 is kind of like density. So what you have is a situation where, because we talk about a ground state, and so a particle will draw in a charge, it'll jump up, and then it will jump down. That's what we say. But that's just one way to look at it, man. That's just your perspective. From my perspective, what you've got is you're packing the particle actually in. The photon goes in, there's more energy, there's more of a dimple, and then when it's gone, it pops back up. So this is key, because when we talk about 1s, we talk about them being the high bit, and when we talk about 0s, we talk about them being the low bit. I will not be doing that. I thought I should justify that briefly. Okay. Mathematics. Did the best I could. Computers. This is the key one. So nobody really wants to be controlled by a hieroglyphic priesthood, right? If you're down with that,
Please raise your hands. We would like to keep you here.
So it turns out computers aren't actually hard to do on purpose. My trade is blameless in this respect for now. They've been advancing so fast that the only thing that we could think to do is build on other people's developments. Fair play and all. But the first time that happened, we ended up with a bunch of priests and hieroglyphs. And it took a revolution to free the phonemes and, the Hebrews and make the world the interesting place that it is. So what we want is a computer that we can all understand from the top to the bottom, which shouldn't be so hard, in my opinion. To get there, we do need some math, and we need to get good with it. But that's not so scary because most of it ends up being just counting, and not even arithmetic, just counting. So what can you do math with? Or what can you calculate with? What can you do computing with?
A slide.
A machine. Yeah. And the early best one, the slide rule, can't work as an analogy just because the logarithms. I kind of got to use abacus. There's a lot you can do with those, and when you look at empires like the Inca, they never quite got to writing. They actually just kind of took what was essentially abacus style logic, and they went really, really far with it and ran entire kingdoms. We've replaced all of that with something that doesn't actually have to be any more complicated than it, while still